This SRAM strategy. OpenAI has finalized a custom system on a chip design that prioritizes SRAM density over traditional compute cycles. This architecture choice is a direct response to the memory wall that limits inference speed on standard mobile processors. By moving the model weights closer to the processing units, they are aiming for a significant reduction in the energy cost per token. This is not about raw speed for the sake of it, but about making real-time voice interaction viable without draining a battery in 2 hours. The silicon is being built specifically to run a pruned version of their latest transformer architecture rather than general-purpose mobile applications. The Apple Exodus strategy. The recruitment of over 40 former Apple designers, including Jony Ive and Tang Tan, is a calculated move to solve the friction of the glass slab interface. These designers are not just there for aesthetics. They are tasked with building a device that replaces the app-based paradigm with an ambient interaction model. The goal is a hardware layer where the model has constant access to camera and microphone streams without the privacy permissions and background process throttling imposed by iOS or Android. This design philosophy shift is exactly why the team includes high-level veterans who understand how to integrate hardware and software at the kernel level. Bypassing the OS bottleneck. Current mobile operating systems are the primary hurdle for low-latency AI agents. Every time a model needs to access the microphone on a standard phone, it has to navigate a stack of legacy software layers that add hundreds of milliseconds of lag. OpenAI is building a thin client OS that gives the model direct memory access to sensor data. This effectively turns the device into a dedicated peripheral for the cloud model, reducing the round-trip time for a response to something approaching human conversational speed. Think of it like a specialized gaming console, but for inference instead of graphics. However, this level of access raises significant data security questions that a marketing-heavy launch will likely gloss over. The thermal reality check. Running a 30 billion parameter model on a handheld device creates a thermal profile that would melt a standard lithium-ion battery in minutes. To solve this, the OpenAI device uses a hybrid inference strategy. The custom silicon handles the initial token processing and attention mechanisms locally, while the heavyweight matrices are processed in a distributed cloud cluster. This is the only way to achieve sub-100 millisecond latency without a cooling fan. However, this creates a massive dependency on high-bandwidth connectivity, making the device a brick in low-signal areas. This engineering trade-off shows that OpenAI is prioritizing interaction speed over reliable offline functionality. The architecture of agency. The OpenAI hardware project is a tactical move to bypass the API tax and the latency bottlenecks of current mobile platforms. By vertically integrating the silicon and the model weights, Altman is attempting to own the primary input-output channel of the user's life. This shifts the value proposition from app-based utility to system-level agency, where the AI is the operating system rather than an application running on top of it. If the SRAM-heavy silicon works as the paper suggests, it would mean the end of the phone as a general-purpose computer and its rebirth as a dedicated interface for a high-bandwidth inference engine. This is a high-risk gamble because it requires consumers to carry a second device that is useless without a persistent network connection. Watch for the first developer kits to ship this winter, which will likely reveal the true throughput and token costs of their custom neural processing unit. Subscribe for more.